Hello, my name is Rich Howard, owner of Architectural Builders Supply, and this video is to bring you a closer look at the Bommer number 7813-601. This is a horizontal spring pivot with floor plate, medium duty, non-hold open, steel trim, bright black japanned. So all of that entire mouthful describes what we are dealing with here. This is a floor-mounted double-acting pivot, a spring-biased pivot. And the intent of this item is to obviously allow your door to swing in both directions, but then to self-center and come back closed. The typical application for this piece of equipment is generally residential in nature. And residential in nature meaning you're going to see it in homes between a hallway and a dining room, a kitchen and a dining room, a kitchen and a hallway, whatever it really might be. You generally won't see these in commercial applications, but I have seen them. Movie theaters, I've seen this from the kitchen area to the, like a hallway. I've seen them there. But that application, that commercial application, was very wrong because that was a fire-rated wall because it was a path of emergency egress. Anyway, so this would be non-fire rated. But in residential applications, you'll see it in those situations, and this, or those uses. This piece of equipment is several decades, if not a century plus old. I've personally seen these in applications that were built in the 1940s. My great-grandparents' home, in fact, was completed in about 1942, plus or minus. In the 80s, when I was there, their pivot worked in 1985 the way it did in 1945, that Bommer pivot, and you'll find that this is an incredibly robust piece of equipment. In fact, I've never heard of one of these fatiguing or failing. I've never heard of one of these breaking or needing to be replaced from Bommer. What I have heard is other manufacturers' material I have replaced with Bommer because it failed. I have heard of a Bommer hold-open version no longer holding open because of the hundreds of thousands of cycles, and who knows how many points of hold-open. This lobe that's here, it would be different on a hold-open model, but that wears out to the point where the spring is overwhelming the metal that's left, not allowing it to stay in the open position, like in one of the two open positions. So I've heard of it being replaced for that reason. But other than that, no other. I do not recall any other time that it was replaced. You won't really see these in commercial applications, and it's not that they're not robust. We just said that they can last decades of use, albeit residential use. Those doors probably aren't cycled very much. They're probably primarily held open, would be my guess. My great-grandparents' home, that door was held in the open position. And I rarely ever saw that door actually close, so it was always held open. Although I played with the door, and I would, cycle it. So you don't see them in commercial applications, and again, not because they're not rated. Like a grade 1 would be 1 million cycles, a grade 2 would be 500,000 cycles. This doesn't carry a grade rating. I don't think that would preclude it from use in a commercial application. I think what possibly would is that this is a spring. We don't have any control over its movement, really, other than adjusting the spring rate. There's no way to dampen the release of that spring. When you are in the open position, the release is the release, whereas in a overhead concealed door closer in the header, an overhead concealed door closer in the door, a floor closer, those will all have springs involved, but they'll also have fluid involved that when that spring is allowed to release its stored energy, the fluid will counteract the speed at which that occurs, allowing you some control over it. You don't really just want a door clanking through its cycle to the point where it gets closed. So a commercial application would probably be better served with something that has hydraulic control over it. As would a residential application, it's just, there's a substantial cost difference between a moderately priced floor spring versus an overhead concealed, hydraulic controlled door closer. But in terms of this pivot lasting in a commercial application, I really wouldn't think that it would be a problem of it lasting in terms of its durability. Again, it's not fire rated, certainly, and it's certainly not handicap compliant because you have no way to control that closing speed. The fact that it's double acting doesn't mean anything. It's just you need so many seconds to come back to the closed position, and there would be no way to really slow this down to where it would still close the door and do it slow enough. And the NFPA 101 would give guidance in terms of that handicap compliance, as would, of course, the A117 document, the federally published document for accessible buildings, that design guide, so to speak. So let's talk about what this item is in particular. This is in particular a adjustable spring, non-hold open, medium weight, which is 90 pounds, with a floor plate. Okay, each of those can be yes or no. It can be hold open or non-hold open. Pardon me, hold open or non-hold open, adjustable or non-adjustable spring tension. It can be light, medium, or heavy duty, 35, 90, or 150 pounds. It can be a floor plate or a floor plate with a jam bracket. So all those are variables. There's another variable, which I think is the fifth variable, is the cover plates can be made of steel or brass. This is made of steel. So all of those variables can be brought into play with this. Now let's move on with a visual tour of the rest of the products that we get. This is, obviously the business and the floor portion of this item. Put that aside. Probably next would be the floor plates, or the cover plates. These are, again, made of steel. This is the 601 Bright Black Japanned, is what this is called. Black has been a finish that has existed in the hardware industry since hardware has existed. Okay, centuries long. When I started in this industry in the 80s, in 1990, black was nowhere to be found really. Bommer made bright black japanned hinges, but black locks, black closers, black kick plates, none of this really existed as black. Well, black, the year now is 2020. The year we're all trying to forget as we live through it. Black has reemerged in the last couple of years and has become quite popular. This is 601. That's bright black japanned. So this does have a reflection to it. I mean, you can literally see my reflection in it. If you looked at old catalogs, you would see a black japanned, but it would be called dead black japanned. It would be quite flat. That's not offered. And Bommer does not powder coat any material. So the black that they offer is a 601 bright black japanned. 601 means steel-based material, bright black japanned, so it's somewhat reflective. Could you have these powder coated by someone, maybe in a flat black? You can. Powder coating will certainly leave a different texture, and those people who powder coat in black will call it suede. This is a smooth, very smooth finish. A black suede powder coat, which is a black suede paint, which is powder coated, will have a texture to it. And I think that's why the marketing people there use the term suede. Suede has a texture to it. Now there are two plates naturally. They're identical. I won't take the other one out of the packaging because it's identical. Overall width about 9 3/4. Overall height about 1 13/16. They're identical, and that's unfortunate. The only thing I regret about this 7800 series is that you don't need all 4 holes in these plates. And that's because in the first time I machined a door for one of these, I realized, okay, make my door look like this piece of paper in front of me, which is included and we'll go over, which is basically just notch the door out like this. Pretty simple. This gets mortised, this gets mortised to the edge. Otherwise, you're cutting out a rectangle out of the bottom of the door. Well, when you cut that rectangle out, those 2 bottom holes have nowhere to go for those screws. There's nothing there left over. I've had, in 30 years, I think 3 customers have called and said, hey, what am I supposed to do with these 2 bottom holes? Yeah, I know. What I would like the factory to do is to make the plates handed, one left hand, one right hand, and omit these holes that you can't use. I've told people, before you do your installation, lay that flat. take your screws that are included, and you do get, the funny thing is there are 8 holes but only 4 screws. They know you can't use all 8 holes. There's 2 plates, 4 holes per plate. I tell people, take that screw, cut it down, lay it flat, get some super glue in there, lay that screw down nice and flat, and let that set overnight, is what I've told people. And the last person that I spoke to about doing that, I said, well, it'll be funny in 50 years when someone's taking that plate off and, whoa, someone glued that screw in. So that's what I've told people to do. I would personally do it myself. I wouldn't want to see an empty hole there, is the bottom line. But that's the design of this item. That's what we get. That's the bottom line. Let's put those aside and continue on with our visual tour. Now, staying near the bottom of the door, we do have this heel plate that's here. And the heel plate literally gets attached or screwed to the base. So that's how you finish this off. And then your plate wraps over the face of that. That heel plate has a radius to it. And we're going to talk about the radius when we look at the template and installation instructions. These are meant to go onto radiused edge wood doors. Okay. And that concludes everything at the bottom. And we'll talk about how to set the tension, but since we have this here in our hand now, let's just demonstrate it. You've got a spring, you've got a tension collar. As you rotate that tension collar clockwise, I think it decreases the tension. Yeah, it does. As I rotate that clockwise, the tension is decreased. And you can just put your tension rod in there and turn that so that you can affect the position of that spring, which will control the rate that the spring is being compressed. So that's how you set that. I have seen Bommer models, and I'll put the tension rod on the other side, where the shaft has also moved at the same time. The shaft I've seen them where they've been allowed to rotate. If your model did that, it's a simple matter of put a pair of pliers on that shaft as you set your tension. I have seen that in 2019. I saw a couple of them that were like that. And I contacted the engineer at Bommer and said, hey, listen, I see this happening. Just confirm, I'm just going to put a pair of pliers on that shaft and hold it still. And he says, yeah, just do that. And that, of course, worked perfectly. Moving up the door now, we're going to have your 7890. The part number of this is a 7890. Screws will be included with it, which are completely in this bag of other screws as well. You can buy these 7890s separately. You can buy that bushing separately as well. I have had people buy the 7890s for use in other applications. I've had people buy them because they've worn them out. Not in the 7800 series, but in the 7500 series. I've had people wear out those bushings and wear out this steel. They've cycled these doors so many times that the steel literally wears away. But with that 7500 series, and I'll show you the Bommer catalog and you can investigate it, it can handle a pretty heavy door. And these doors were at the outer limits of weight, and they're short doors. They're like 40-inch tall. So there's a lot of mass in a very small amount of height of door, wear and tear on that pivot. Now, not really on a 7890 would you have that sort of 7500, but the post and this plate along with the bushing is the same in that series, really, and that's what's been replaced. Finally, you'll get your screw package for everything, and then your tension rod to set your tension. That, also you'll get installation instructions. Now that gives you a visual tour of everything that's in the box. Let's now switch to the screen view where we can take a closer look at the supporting documentation and the extended description. Here is the item that we are looking at. And before we go into the extended description, let's just talk about the different finishes. Bommer and the capability of finishes are quite remarkable. Bommer can produce over 30 finishes, 33 or 36. They have an entire plant that does nothing than the plating of their product. It's physically separate or separated from the manufacturing plant by about 15 or 20 miles, whatever it is. And I've been to that facility. I've met the person who runs it. Absolutely intriguing, the process of plating, all of the different finishes and base materials that can be done. Some of the other work that they do there to make the components ready for plating is really fascinating. The fun fact about their plating plant is the waste water that they eject into the surrounding area is cleaner than the municipal water supply. And there's nothing wrong at all with the municipal water supply. The point of that is their plating plant is just that clean of a footprint within the greater environment. So really fun fact. You can do a 332, a bright brass clear coated, but not polished. I would say that would probably bright brass plated. That's going to be like, I believe a 332 is going to be a bit more of a metallic type finish. 372 would be aluminum lacquer. 383, some of these I don't remember, dark bronze enamel. 600 is prime coat. 601 bright black japanned. 603 is a zinc. That's going to be the like a silvery color. 604 is zinc dichromate. That would be like a gold type zinc process for corrosion resistance. 632 polished brass. 633, well, polished brass on steel. 633, well, all of this is steel because it's a 7813. 633 is satin brass. 636 is blackened satin brass. 637 is polished bronze. 638 is a blackened or an antique satin bronze. 639 is just satin bronze. 640 oil rub bronze. 643 is a blackened satin bronze. Satin bronze plated blackened. Satin bronze plated blackened. 638. This is going to be more like an antique brass. Is what a 638 is, I believe. Let's do a little deeper dive into that. If you want to see finishes, contact us, and then over here, video gallery, go to page 2, and then do a find function on your keyboard for BHMA. BHMA finish chart. 638. Yeah, that's a satin brass blackened. So that's an antique brass, a 638. Yeah, the 638 here should say not satin bronze plated, but satin brass plated. So that's a typo, and we'll get that corrected. 638 is satin brass. Anyway, 645 is polished nickel. 646 is satin nickel. 647 is an antique nickel. 648 is a, well, .648 is going to be like an antique polished nickel. I don't think I've ever seen that finish. 651 is polished chrome. 652, which will be the next one on the next page, is going to be satin chrome, and that would be the last finish. So there's a few finishes here, that's to be sure. So there's one on this page. So there are 21 finishes here. There's 20 on a page. And that's only on steel. You change the base material, okay? Now you've got different finishes. So if you go from steel to brass, or if you go from steel to stainless steel, so you can see where all those 30-plus finishes really come into play. It's really great stuff. Now, let's slide down here to the extended description and take a closer look of what we have going here. Steel trim with a floor plate, and that means your pivot will have this floor plate. There's a jam bracket, which I'll talk about in a moment. Double acting and non-hold open, adjustable spring tension. We talked about all this. 1 3/8 to 1 3/4 thick doors. Now, will it work on an 1 3/8 door? What I should say is, will it work on a thinner door than 1 3/8? Probably not. The hardware itself is going to be literally too thick to fit onto a thinner door. Will it work on a door thicker than 1 3/4? Sure it will. But everything that will be in the template and the installation instructions will go out the window because your margins will have to change. Because you're dealing with a thicker door, depending on how you're going to treat the edge of that door. If you're going to leave the door square-edged, or you're not going to radius the door, you'll have to you know, work off of the work away from the template and installation instructions. It can work on a thicker door. You just have to make sure the margins are correct. The way it's been tested, however, is with an 1 3/4, 1 3/8 door range. Speaking of testing, 3-foot wide doors, wider than that, will it work? It might. It might not. I would think that the width, the height, the thickness will all conspire. And these dimensions here, or this range here, is what it's been tested. This is where it's been known to work. Have I heard of people installing this on wider doors? Yes, of course. You know, on thinner, on narrower doors? Yes, of course. You know, the question really becomes is, you know, your mileage will vary depending on the width of the door. You have a wider door, you'll have more air that you physically need to move out of the way as the door goes into its closing cycle. So all of that will conspire to give you a specific performance out of the unit based on your exact door envelope. 90 pounds would be the maximum weight for this. Will it work on a 40-pound door? Sure it will. You get into the much lighter door, you need to look at the other pivots, which we'll go over in a moment. Okay, there are two supporting documents, template and installation instructions. Before we get to that, let's go over this table. Now here we have a table that will allow you to review the 7800 series in its totality, seeing it all in one place at one time. And all of them are going to look the same. Okay. So the question becomes is how do you discern which model you need to order? 2, 4, 6, 8, 10 models. How do you discern which one you need? Well, let's break it down. First of all, the easy thing that I would always ask is, what's the door weight? 35 pound, 90 pound, 150 pound. That's going to put you into certain rows. After that, I would say, do you need hold open? It's either yes or no. Do you need adjustable spring tension? It's either yes or no. Do you need a jam bracket? It's either yes or no. And do you want the side plate material made of steel or brass? They're almost all made of steel. The 7821 is the same as the 7811, with the exception that the plates are made of brass, and the 7822 is the same as the 7812, with the exception that the plates are made of brass. Now, why would you want brass? Well, brass as a base material is going to give you a different finish that steel would as a base material. So if you're going to do bright black japanned, I wouldn't order brass. I would just let that be steel. But if I was going to order polished brass, and I wanted it to be as faithful to a true polished brass, I would opt for the brass-based material rather than plating over steel. Okay. So you would use brass when you want the most faithful finish. If you want the least expensive, you don't order brass. If you want the most faithful finish and cost is secondary to that, then you would go with brass. Okay. There are 3 weight ratings, 35, 90, and 150. The 7811 is by far the most common of all time, period. Probably followed by the 7801, 35 pound or 90 pound. The 7811 is hold open and adjustable spring tension for 90-pound doors. That's pretty much going to be everything that you're going to run into in a residential application. If you had a much thinner door or a smaller door or a lighter door, and it was in that range, 7801 would work just fine for you. So use this table to get to the items that you need, and the link here will take you to the page where you can see it listed with all of the possible finish options. Okay. Any videos that we have of them will be in this column here. So that's a handy table. Now, let's dive into the supporting documentation. We are going to have the template and the installation instructions. Let's look at the template first. Both documents are important to have. Okay. They give different information, but you need them both. I don't know that you can work only with the installation instructions. Yeah, you can, but you like to have both documents. Admittedly, both of the documents are not in the packaging, only the installation instructions. Because, actually, in all fairness, everything you need is on this page. But here is the, let's start with the template. The template goes over a dimensional review of all of the components in the top third. We're not going to spend a lot of time looking at this, just to understand it's 3 and 9/32, height of the mechanism plus 9/16. And that should be a tip-off right away in terms of what your undercut's going to be. Your undercut's going to end up being 9/16 based on all this dimensional property. So what does that mean? Let's just talk about the undercut. Yeah, it's referred to here as well. So can it be more? Can your undercut be higher than 9/16? Well, I imagine it can, but you're going to need to put a block underneath the hardware because all of the math between the bottom of the plate and the bottom of the mechanism is 9/16. So if you had an undercut that was going to be 3/4 inch, you're going to need to put something underneath this to build it up, is what you'll need to do. Could you use an undercut smaller than 9/16? Yeah, you could. You're just going to mortise that all deeper into the door and let that come down over the door, and this will be mortised up higher as well. And why would you need to talk about the undercut? Well, you have an existing door. You've got a door that is, 79 and, 1/4 inch. Will that work? Well, it's not exactly correct because if you have a 6/8, an 80-inch finished opening height, you need 9/16 here. You need 1/8 of an inch for the top of the door, 1/8 of an inch minimum clearance. So that's going to be 11/16. So, will 79 1/4 work? Well, you're a 16th off. Something's got to give a 16th. You don't really want it at the top of the door because you want that pin to be fully engaged into the door here. Okay, so 9/16. When you're doing a new installation, 9/16 is your undercut. So your finished opening minus 1/8 of an inch minus 9/16 is your net door height. Now the bottom 2/3 of the document give us all of the other dimensional properties that we need. Over on the right side is the dimensional properties of the heel plate, or what they call back plate, the top pivot, and then the face plates, the finish plates. We don't really care about those. They are what they are. Well, yeah, they are what they are because everything we need to look at is over on the left side. Okay, so your top pivot, let's talk about the top pivot. We'll start at the top down. They're saying that those are 7/8 diameter, which makes sense because it's a 7/16 radius. 5/32 deep. You'll do that same preparation in the top of the door and in the underside of the header. How will you prep that? I would probably use a Forstner bit. I would drill 3 holes with my 7/8 diameter Forstner bit, 5/32 deep is what I would end up doing. Okay. Routers, bits, guides, table saws, all of those are the stock and trade of the woodworker. The caliper has to be at the very top of the list. I wouldn't do anything without a caliper when it comes to woodworking. You need to measure how big your template is set, how large a piece of hardware is, the caliper. The caliper is the first investment in a wood shop, in my opinion. I've been using one for decades, and I would not be able to exist without it. Just since we're talking about calipers, I don't use a fancy electronic caliper. I just use our good old-fashioned stainless steel caliper, the Toyo 504-505-718. This is not the exact model I have, but it might as well be. Actually, it might be. Looking at my caliper, yeah, the color's off, but yeah, mine is. These come in different colors in terms of the faceplates as well. This is how you survive in a wood shop. Now, that's how I would prep the top of this. Then you're going to need, of course, a 5/8 diameter hole drilled down in the center of the door only for your pin to come down. Now, where do you place it? Well, that's easy. 1 3/4 from the jamb to the center line is where that's going to be placed. Okay, it's 1.5 inches from the edge of the door, but the center of the thickness of the door to here, and they're saying give yourself a 1/4 inch over here. I would say that that dimension can be less. I would think you should be able to survive with that being 1/8 of an inch, or 3/16 for sure. And that's the other dimension, is the width of the door. So what they're telling us here is that they want a 1/4 inch margin on the pivot style. They don't tell us the opposite side, but let's say it's the same, so that you have an equal margin between the door. I would be personally making that 3/16. So what's your finished opening? If it's 36 inch, well, you know you're going to be at 35.5 inch for a door width, or maybe 35 5/8 maximum. So that's the other dimension to be to take note of. Now let's work down. I had initially said, well, notch that door out so that it matches that piece of paper. Well, here's the piece of paper. And how you go about accomplishing this, the first time I did it, I used a skill saw to remove as much of this as I could. I think I used a hammer and chisel for the rest, which was brutal. I would not encourage you to do that. The next time, it would be a piece of wood, like a 1x piece of poplar, that I have cut in this sort of fashion. I've clamped it to the door so I could run my router over it. And then the only thing I'd have to do is get in there where necessary and square the corners. That would be necessary here and here, and I highly doubt you would have to square the corners here. A router is the way to go. A nice plunge router, making multiple preps down through the door. If that template can be non-handed, it can be such that all you do is flush it to the edge of the door and the bottom of the door, clamp it down, and you're off to the races. You can do it halfway deep on each side of the door, flip it over, move your template over again, and you'll get a really clean look. Very, very fast, very professional. Everything in woodworking should be done with a router when possible. So pretty easy prep. 1 7/16. You can read all the dimensions. Okay. Now, what's super critical to maintain is that 1 3/4 inch, and that's the vertical axis of pivoting. You don't really see that hardware referenced here, but on the hardware itself, here's the vertical axis of pivoting. Okay? That vertical line needs to be true, plumb level, and square with your top pivot. So if you maintain 1 3/4 inch from the jamb to the center line, at the top and bottom, it's going to fit exactly where it needs to be. Okay? Obviously, the 5/16 deep prep is what's governing that, so be mindful that that's what you're accomplishing. And again, all of these dimensions are referenced from the high side of this opening, not from here. Right from here. That's the width of the door. So that's how you prep everything. Let's move to the installation instructions, and they give us a lot of the same data, so we don't really need to talk about that. But the one item we've not discussed directly is the step 1, the radius. They're calling out 1.5 inch radius for this. Can you leave your door square edged? You sure can. You can definitely do that. That margin, depending on your door thickness, will certainly need to be a 1/4 inch. I don't think it'll need to be any greater than that. Or can you change that radius? Maybe you don't have a 3-inch diameter round over bit. That's not pretty typical and common. Can you take a square edge door and just put a 3/4, a real tight, an artist I am not. Can you do something like that to break those edges? Sure. Can you do a heavy chamfer on those? Well, based on your door construction, you probably can. But the factory's calling out 1.5 inch radius. That makes for a large round over bit, very large. I, of course, own one. I've done this sort of radius prep countless times on doors. It's very easy, very simple and straightforward. But you do need a big round over bit, and you need a router that can handle it. The router I use was a DeWalt router that I took the base, because the base of your router, your router base is round, right? Well, here's where your collet goes through. Then a router base has these holes like this, that sort of business. I took, to fit that giant bit through, I cut all through these holes and gave myself a giant hole. The downside of that is you have much less of a surface area to keep that router flat on the face of the door, but nonetheless, that's how I've done it. I would set it at the proper depth based on my door thickness, and I wouldn't change it. I would leave it set correctly, and that's how I would prep it. You'd put the door down on sawhorses. You would clamp it down. You would run that treatment down on one side, take your door, flip it over, do that treatment the other side. Make no more than 2 passes. Your first pass does the job. The second pass cleans off any rocking that you've done, but don't rock the router. And when you exit the door as you're traveling this way, don't push the router that way or you're going to round over the face of the door. Again, you don't have to radius the door edge. It will still work, but your margin of 1/4 inch, you could certainly never be less than that. I don't know what the hard margin is because I've not put it into an AutoCAD program, but nonetheless. So this is all duplicate. This is all duplicate. The only thing that they didn't show, I think, on the instructions, yeah, they don't. You're going to need to slot this most likely down in the bottom of the door right here because the hardware itself, right where this, there is, I think the design has changed. Actually, I know the design has changed. You don't need that actually. The design from years ago certainly required that slot to be done, but the top of this hardware, they've clearly changed the design. There used to be a traveling pin inside of here. Well, that pin is now fixed, so they've redesigned that. So you don't need that. You'll see that. This you're not going to need. If you prep it, fine. It just won't be used. So we can jump to step 4 because the door is prepped now. Attach your hardware to the bottom of the door so it looks like this. Pretty straightforward. Screws are included. Your top pivot, of course, has to be attached to the header and to the top of the door. And you're literally going to do what they're showing in step 5. What I would do is I would get it into position. I would make sure that my margins were uniform, they were accurate, they were symmetrical. I would make sure my door was positioned properly within the opening so it wasn't canted in or out or toed at all. I would mark my holes in the floor. I would remove the entire door. I would drill my holes, put the door back in, then I would secure it down to the floor. Then lastly, I would attach my faceplate. And then again, you're going to... this one and this one will be empty. Okay. A couple of screws here and here. Heel plate obviously goes on first, the back plate. That's it. That's how this is done. This document is from 2003, drawn by Stuart Jackson. He is, in my mind, a living legend when it comes to the engineering of hinges, all things hinges, especially spring hinges. It will be a loss to the industry when Mr. Jackson retires, which unfortunately I don't believe is too many years down the road. Hopefully it's a couple of decades. A real amount, a substantial amount of gray matter involved here when it comes to all things hinge related, especially in the Bommer product line. Now, speaking of the Bommer product line, there's a link below this video here to the manufacturer's page. When you click on that, you can pull up not only all of the Bommer products we sell by means of this horizontal navigation, but also a link to the manufacturer's website, as well as a link to the full product catalog. Now, that full product catalog, that's a lot of fun because it will allow you to review all things Bommer related. We can just get to the 7800 series by doing a find function on our keyboard. You're going to get to right where this is seen. And by the time you're seeing this video, this 2-page product catalog will be linked down below this video as well. Really what it is that table that I showed you earlier, that we just basically took that table and expanded it slightly. Then it will give you an overview of what it is. Okay? Then the individual part numbers that are listed in the table on pages 1 and 2. That jam bracket is there. Why would you and when would you use a jam bracket? You would use that when you cannot or will not drill into the floor through the floor plate. Why wouldn't you? Is because you don't want to. You may think to yourself, well, I don't want to run the risk of cracking this tile. Why couldn't you? Is maybe you have radiant heat in the floor, or maybe it's an application where you're not permitted to drill into the floor. There might be something happening below it. and you would then take your assembly and you would screw that down to the floor, pardon me, the jam bracket. You would attach it, then this would get attached to the jam itself. It's not mortised, although you could mortise it, but then your gap is going to change because these holes are fixed for a non-mortise installation. Your pivot assembly is also referred to here. Pretty simple and straightforward. The rest of the catalog, however, is quite comprehensive when it comes to the entire Bommer product line, which is going to include all things hinge-related, spring hinge-related, single and double acting. In fact, it was the brothers Bommer in 1876 who started Bommer and invented the entire product category, of which they've been copied and cloned countless times over the decades and century plus. So suffice it to say, if you've ever seen a double-acting door, it's because of Bommer. And this Bommer hinge here, that's the 3029. It's the most common of all double-acting spring hinges and has been duplicated, copied and cloned countless times. A very interesting walk through the world of spring hinges are here, but they make more than spring hinges. They make standard commercial grade hinges as well, a variety of applications, base materials, sizes, obviously finishes. Here's a BHMA code here showing their finishes as well. That's pretty handy. Encyclopedic information in the front of the catalog, which you can go over. Probably the last thing that I'd like to point out to you would be the lavatory hardware that Bommer has. They have a comprehensive offering of lavatory hardware made of solid brass that you'll see in high-end hotels and law libraries. You'll see all this high-end lavatory hardware. Occupancy indicator as well. So interesting material that you may not have known Bommer makes. Let's wrap up this video on camera. In conclusion, I'm quite partial to the name Bommer, and it's because I believe in the product line, I believe in the people, whether it be the engineering department, certainly the customer service department, ownership, the people in shipping and receiving. Pound for pound, they're the best fighter in the game, in my opinion. And the Bommer logo, right there on the floor plate. Right above it, it says Made in USA, a fact that Bommer is quite proud of, as am I to represent them. If you have any questions on the Bommer 7800 series or any other Bommer product, please feel free to reach out to us. And thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.